everybody. Today we are going to be discussing how to use the midpoint formula, the distance formula, as well as the Pythagorean theorem to try to find distance as well of segments. So our first example here is dealing with the midpoint and the midpoint formula. So we're given segment AB with its particular coordinates for each endpoint A and B, and we're asked to find the midpoint. First thing you want to do is plot your points. So A is going to be over 4 and up 6. B is going to be left 2 and up 2. You should label your points. That was B. This is A. And we're going to connect these in as straight of a line as possible. So the question is, what is the midpoint? Which means, what is the point that is exactly halfway between A and B? So we're asking about what are the coordinates. So what we want to do is use the midpoint formula. So basically, a midpoint is going to be a point as well. So you need to have an x-coordinate, then you need to have a y-coordinate. What you want to do is take your two x-coordinates of the given endpoints. So in that case, it's 4 and negative 2, and we want to average them. Or take 4 plus negative 2 and divide by 2. 4 plus negative 2 is the same thing as 4 minus 2, which is 2, divided by 2. 2 divided by 2 is 1. That means the x-coordinate of our midpoint is 1. And to find our y-coordinate, we're going to take our y values, which are 6 and 2. We're going to add them together. 6 plus 2, and divide this answer by 2. So what we have is 8 divided by 2. And then 8 divided by 2 is 4. So that means our midpoint of line segment AB, and you can use M to call the midpoint. You can label the midpoint any letter you'd like that's not already in use. A and B are in use. You have to pick a different letter, so might as well use M. Our x-coordinate is 1. Our y-coordinate is 4. And yes, you may absolutely plot that point as well. Actually, let's do something other than red. So we're going to go over to 1 and up to 4. So this is the exact middle of our line segment. The next thing we want to do is to, instead of find the middle of line segments, is find the exact distance of any given line segment. So here we're given point E, point F, point A, and point B. We are asked to find the distance of EF, as well as the distance from A to B. So it would be the length of segment EF, the length of segment AB. And then a follow-up question would be, is segment EF congruent to AB? So the first thing we want to do, one of our specified segments is EF. So let's go ahead and plot E and F. So E is over 5, up 6. F is over 1, up 2. We'll connect those segments. Let's now sketch segment AB. So A is over 6 and up 1. B is over 2, and the y-coordinate is 0. Whoops, that did not actually connect very well, so let's try that one more time. That's a little better. So this was A, and this is B. Now, just visually looking at our graph, or if you sketched yourself an x and y axis, it doesn't look as though these segments are the same, but in math you do have to prove it and show that for sure they are or are not the same, as in they are or are not congruent. So to do that, we want to use our distance formula. So the first thing we're going to do is we're going to find the distance from E to F. So using our formula, and it absolutely helps if you list your points vertically, because what that does is it helps you see your points lined up in terms of x and in terms of y. So just remember, everything that's in the first position are x's, and in the second position are y. So we're looking at E and F right now. So our formula says we have the square root of our x values subtracted. So 5 minus 1, because these are both the x values dealing with E and F. So 5 minus 1. And then once you find that difference, you'll square it. You will add to that result the y value subtracted. So if you refer to E first with the 5 and F second with the 1, you need to have the same pattern when you do your y values. So 6 is part of E's coordinates, so you have to do 6 minus 2, not the other way around. You do want to stay consistent. And then you'll square that result. So you always want to follow your order of operations when simplifying. So we have square root. 5 minus 1 is 4, and it does still need squared. Plus, in parentheses, 6 minus 2 is 4, which does still need squared. So continuing our path, 4 squared, that means 4 times itself, or 4 times 4, which is 16, plus 4 squared again is 16. Next step is to add our 16. So 16 plus 16 is 32. Now, you should follow your rules of simplifying a radical back from Algebra 1. And where we want to think about factors of 32, where one of them is a perfect square. So perfect squares are things like 4, 9, 16, 25. And we already know that 16 is involved in 32. In fact, 32 is the same thing as 16 times 2. Square root of two things multiplied together, you are allowed to break that apart and make it the square root of each one individually multiplied together. The square root of 16, that's saying what times itself gives us 16. Can we break 16 down into two identical roots? In which case we can, because the square root of 16 is 4. This is still times the square root of 2. The square root of 2 cannot be simplified any further. So I'm going to switch colors here just to show us the two different problems here. We found that the length of EF, it is 4 root 2. Now we want to find the length of AB. Okay, so again, A and B. So we're going to have our square root of the difference of our x values, so 6 minus 2, and square it, plus the difference of our y values, 1 minus 0, and square it. So now we're going to follow order of operations and simplify in parentheses first. 6 minus 2 is 4. We're still squaring. Plus 1 minus 0 is 1. And we're still squaring. So 4 squared, that's 4 times 4 is 16. Plus 1 squared, 1 times 1 is 1. 16 plus 1 is 17. And you want to think to yourself, can I simplify this at all? Are there any factors of 17 where one of them is a perfect square? The answer is no, because 17 is actually a prime number. So 4 square root 2 is as simplified as it can be. Square root of 17 is as simplified as it can be. So the final question was, are these two segments congruent? And for two segments to be congruent, they must be the same length. We got two completely different lengths for these values. So that would mean that EF and AB are two completely different lengths, which means they are not congruent. So your final answer would be no. Another thing you can use to find distance to make it a little bit easier is to use the Pythagorean theorem. And you want to use the Pythagorean theorem when you can create a perfect right triangle, which you always can if it's just a segment that you're trying to find the distance of, or the length of. So again, we're given points A and B, so we want to plot them. We want to go 0 up to 3. This is point A. And for B, we want to go over to 4, and then the y coordinate is 0, so we don't have to go up or down at all. do is connect our 2 points. This is the segment that we want to find the distance of. Now to determine what your x and y values are, you always want to figure out the 2 legs of the right triangle. So what that'll be is connecting the 2 segments to form a right triangle. So this is always a right angle. So it's basically how tall, or what is the rise from B to A? So that would be this value right here. And then what is the run from B to A? So that would be the distance of this leg right here. So from B to A, we have to go up 3 units. And from A to B or from B to A, we have to go over 4 units. So you can kind of picture we've actually created a right triangle with one leg 3, because remember this is the right angle, one leg 3, one leg 4, and the hypotenuse, which is the distance from A to B, we'll call it x. Pythagorean theorem says a squared plus b squared equals c squared. I like to think of this as one leg squared plus the other leg squared is always equal to the hypotenuse squared. That way you know that the legs are always on the same side of the equation and the hypotenuse is on the other. So substituting in our values, we have 3 squared plus 4 squared equals the hypotenuse squared. We don't know what the hypotenuse is, so we're going to leave it the variable x. 3 times 3 is 9. 4 times 4 is 16. And we still don't know what x is, so we will leave that as x squared. 9 plus 16 is 25 equals x squared. At this point, x squared equals 25, but we want to know what the value of actually x is. So the way you get rid of a square is by square rooting. Square and square root cancel. So we are left with x equals, and the square root of 25. So what times itself gives us 25? The answer would be 5. So the Pythagorean theorem allows you a different way to use the distance formula. Had you used the distance formula with these 2 points, you would have arrived at the same answer. X equals 5 units.